Alright, let's dive into the fascinating world of geochemical data analysis, focusing on a systematic approach called Geocoda. Imagine you've just collected a bunch of rock or sediment samples, sent them to the lab, and now you have a spreadsheet full of numbers representing the concentrations of various elements. This is where the fun, and sometimes the frustration, begins. Geochemical data is inherently compositional. What does that mean? It means that the values you have for each element aren't independent absolute amounts. They are proportions of a whole, usually summing up to 100% or some other constant when expressed as oxides or just representing relative abundances of elements. Think of a recipe. If you increase the flour, you might need to decrease the sugar to keep the proportions right for the cake to work. Similarly, in geochemical data, if the concentration of one element goes up, the concentrations of others must relatively decrease because they all contribute to the same total. This constant sum constraint is a big deal. Why is this constraint such a headache for geologists? Because standard statistical methods, the ones you probably learned in school, assume that your variables are independent of each other. They don't expect that increasing one number forces another number to change just because they re part of the same pie. When you ignore this compositional nature and apply standard stats, you can end up with what are called spurious correlations ***. You might see two elements appearing strongly related statistically, not because of any real geological process, but simply because of the mathematical closure effect, the fact that they both part of the same sum. This can lead to seriously misleading interpretations about the rocks you're studying. It's like saying flour and sugar are correlated in baking because if you use less flour, you must use more sugar to maintain the perfect batter consistency when really their relationship in the recipe is about the chemical reactions during baking, not just their combined weight. So, how do we handle this compositional challenge? This is where compositional data analysis coda comes in, building on the pioneering work of John Aitchison. The core idea in coda is to stop analyzing the raw percentages or concentrations directly and instead analyze their ratios Geologists are already familiar with ratios. We use them all the time, like MgA in igneous rocks, because ratios can reflect geological processes. Coda takes this a step further by using Logratio transformations Why Logratios? Taking the logarithm of ratios helps turn often skewed geochemical data into more symmetrical, normally distributed like data in log space. This makes the data much friendlier for standard statistical techniques that perform best with normally distributed data. It also liberates the data from the constant sum constraint, allowing statistical methods to analyze the relationships between components without the artificial ties imposed by the closure. Suddenly, statistical methods stop scratching their heads and start making sense of the actual geological relationships. Enter Geocoda a systematic workflow designed specifically for analyzing lithogeochemical data using coda principles. The name itself, Geocoda, cleverly combines geo for geology and geochemistry with coda for compositional data analysis. It's not just a single technique, it's a step-by-step guide to help geologists get the most meaningful information out of their compositional data. The main goal of Geocoda is to enable the recognition and validation of significant geochemical mineralogical processes Rocks form, they get altered, they undergo metamorphism, and sometimes mineral deposits are formed. All these processes leave signatures in the chemical composition. Geocoda helps you find these signatures and understand what caused them. It bridges the gap between the raw numbers and the geological story they tell. The Geocoda workflow emphasizes using Logratio transformations to reveal the underlying patterns. There are a few flavors of Logratio transformations, but the main ones discussed in the context of Geocoda are additive Logratio hour, ***, you choose one element as the reference denominator and take the logarithm of the ratio of every other element to this reference. It's simple and easy to interpret, as you're comparing everything back to a single baseline. The catch: if you pick a bad reference element, one that's involved in many processes or has lots of zeros, it can bias your results. Centered Logratio CL are ***. This transformation uses the geometric mean of all elements as the reference for each individual element. It's more symmetrical and avoids the bias of picking a single, potentially poor reference element. Isometric Logratio ILR ***. This is a more mathematically complex transformation that creates balances or contrasts between groups of elements. While mathematically elegant, these balances are often difficult to interpret geochemically, especially when dealing with many elements. Geocoda primarily focuses on our and CLR because they are more interpretable and practical for geologists. By applying techniques like *** principal component analysis, PCA** to CLR transformed data, or other multivariate methods like correspondence analysis, which can handle zeros, Geocoda helps reduce the complexity of a dataset with many elements into a few key dimensions that explain most of the variation. These dimensions, or principal components, often correspond to fundamental geological processes like differentiation, alteration, or sorting. It's like finding the main themes in a very complicated story. Geocoda integrates *** machine learning *** methods to enhance the analysis. This isn't about robots taking over geology, but using powerful computational tools to find patterns and make classifications. Unsupervised learning like clustering, is used for process discovery It helps group samples based purely on their compositional similarity in Logratio space, revealing natural groupings or patterns without needing predefined categories. This can highlight previously unrecognized geochemical associations. Supervised learning such as classification trees or logistic regression, is used for process validation Once unsupervised methods suggest patterns, supervised methods can test if these patterns accurately predict known categories, like different rock types or geological units. It helps confirm if the discovered patterns are geologically meaningful. A key example used to illustrate Geocoda is lithogeochemical data from a Kimberlite deposit. Kimberlites are important rocks because they can host diamonds. The star Kimberlite example involved samples from 5 different phases of eruption. Geocoda successfully identified distinct geochemical signatures for each phase by analyzing Logratios. This allowed the workflow to pinpoint specific elemental ratios that were most effective at distinguishing between these different Kimberlite phases. This kind of insight is incredibly valuable in mineral exploration, helping geologists identify different rock types or mineralization styles based on geochemistry. It goes beyond simply looking at plots and provides a statistically validated way to discriminate geological units. What about those pesky compositional zeros Sometimes, an element's concentration is below the detection limit of the analytical instrument, or in some cases, an element might genuinely be absent in a particular part of a sample. These zeros are a problem for Logratio transformations because you can't take the logarithm of 0. Geocoda acknowledges this and suggests strategies like imputation estimating a likely value for the 0 based on other data, or using alternative methods like correspondence analysis that can handle zeros directly. The best approach depends on why the zero is there, whether it's a true absence or just below detection. Another practical aspect of Geocoda is the use of **AMALGAMTIONS***. This involves grouping elements together based on geological knowledge, for example, summing up elements that tend to occur together in specific minerals or processes. Analyzing Logratios of these amalgamated groups can make the interpretation more geologically meaningful and also help manage the zero problem if elements are summed. It's like combining flour, sugar, and eggs into a wet ingredients group in your recipe. It simplifies things while still representing a key part of the mix. In summary, Geocoda provides a *** systematic, accurate, efficient, and defensible ** way to analyze geochemical data. It guides geologists through the process of properly handling the compositional nature of their data using Logratio transformations, discovering underlying geological processes using unsupervised learning, and validating these discoveries with supervised learning. By applying this workflow, geologists can move beyond the pitfalls of analyzing raw compositional data and gain deeper, more reliable insights into the rock-forming processes, alteration, and potential mineralization hidden within their geochemical numbers. It's a powerful tool for anyone working with geochemical data, helping to transform raw analyses into meaningful geological understanding. This summary is based on the content from the paper Geocoda, recognizing and validating structural processes in geochemical data, a workflow on compositional data analysis in lithogeochemistry published in Applied Computing and Geosciences. Original source: www.sciencedirect.com/journal/applied-computing-and-geosciences.
Welcome to the world of geology and earth sciences with Ricardo Valls, a seasoned professional geologist bringing you over 1,500 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Ricardo Valls not only shares his own invaluable insights, but also brings you exclusive interviews and collaborations with other prominent geologists, offering a comprehensive view of the field. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Don't miss this opportunity to enhance your knowledge and stay at the forefront of the industry. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 2,000 earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Valls, your top resource for all things geology. The future of geosciences is here. Be part of it.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.